Hey there, welcome back to another video, and in this video we are gonna implement our locally weighted regression. So without wasting any more time, let's get into the coding. Okay guys, so this is the data that I am using. So let me just write our formula first. X transpose W X inverse X transpose W Y. So this is our formula, and here W is a diagonal matrix of size m by m. Okay, so first of all we need to create a function to find the W. So let's take get, let's make a function get W. In this we will need 2-3 things. That first thing is going to be X. Okay, the next thing that we need is our target or query point. So query point, or let's take small x. And the third thing is we need our tau. Okay, so the formula for for finding W is e to the power minus x minus x, or you can say xi minus x square divided by 2 tau square. Okay, so this is the formula. Now let's just quickly implement this, and what I'm going to do is I'm going to make a matrix first. So np dot I, and in this I'm going to give the size of x dot shape 0. And I'm going to convert this as np dot matrix normal matrix. Okay, so we will have this. Okay, now the next thing that we will need is we need to query through all the points. So let's suppose we are giving it 2, we are giving our test data as 2. So it is going to go through all the points to check whether it is going to be close to us or not. So it is going to go through all the points. So let's take for I in range x dot shape 0. Okay, and what we need here is, let's take si equal to x I, and we need W I comma I. Now we are going to implement this formula. So np dot exponential, and in this, now when I wrote this formula is only going to work if you will have only one feature. If you want to make it work for let's suppose 2 or 3, or basically multivariate regression, so if you want to use it for multivariate regression in which you have multiple number of features, then for that you have to change this formula a little bit. So what I'm going to do is I'm going to use np dot, and in this I'm going to pass xi minus x, and then again xi minus x dot transpose. So what I am doing here, so let's suppose we only had one values here. We had 6 in this, and we have 5 in this, and we do not have these right now. So 6 and 5, let's suppose we have these values. Now if we will have a matrix, then it will have multiple number of features. So those features could be, let's take 6 3, they are going to be in a matrix, and they are then 5 4, let's take this 5 4. So you have to minus them. Basically you have to subtract them, and then you have to square them. So for for subtraction you are just using the normal formula, and to square them, so for a matrix, so this is the formula. X square is going to be x into x transpose. So this is what I have done here. Xi minus x, considering they are matrix. Okay, and that is going to be dot product with xi minus x transpose. So this is going to be okay. Now what we need to do is we have to square all of this. So this is going to be squared. Okay, and what we need here, we need to also divide it. So let's use this, because we need to divide this by here. Okay, so divided by 2 into tau into tau. So I think this should work, and now we will need to return w. Okay, we will see whether it is going to work or not. Now we need to get all the predictions here. So let's take def predict, and in this, what it is going to take, it is going to take our x, and it is going to take our y, and it is going to take our x text. Okay, so let's also generate x test first. Our x test is going to be x test is equal to np.lin space, and we are going to get the values from, let's take -6 to 7. Okay, -6 to 7, and we also need to get 100 values here. Now if you will see the shape of the x test, so x test dot shape, it is only this, so we need to reshape it. X test equal to x test dot reshape, and we need to give here 100 times 1, 100 comma 1. Okay, so this, if you will see, it will have this. And why do we need to do this? Because we also need to have add it to 1. So let's take x test dot yeah, so np dot h stack, and here what you need to stack. So first of all, x test p dot np dot once 100 times 101, and you need to give x text. So why do we need to do? Because as we saw in our linear multivariate regression or closed form solution, we need to add a column of ones before our x. So we are doing that here. Okay, we are also going to add this in our data, but first of all, let's just complete our algorithm first. Okay, so we will have our x test here. Now what it is going to do, let's take y list equal to this for z in x test. So it is going to take every point. Let's suppose we have these points, so it is going to take this point, it is going to get the w, it is going to calculate every theta, and on the basis of that theta, it is going to predict our value. Okay, then it is going to take another input. Okay, and for that input, it is going to find the theta, then that theta is used to predict another values like this. Then it is going to do the same thing, so let's just do that. Okay, so here we need to pass some things, so x tau. So let's take w equal to and get w. In this we need to pass our x, we also need to pass z, and we also need to pass tau. Let's take tau as 5. So now we need to get our theta here. So our formula is x transpose w x inverse x transpose y w y. So this is our formula and we have to work for that. So a equal to np dot ln alg and dot inverse. In this we need to pass some values, np dot dot, and this is going to be x dot transpose comma w. Okay, so we need to find this, and then again np dot dot comma x. So this is going to complete this step. Then for the b step, let's take np dot np dot dot x dot transpose with w, and again np dot dot, that is going to be with y. Okay, now theta is going to be, theta is equal to np dot dot a with b. Now it is going to get us theta. Now this theta is going to be a 2D array. Okay, and because of that, first of all, let's make some prediction here. So y prediction is going to be theta 0th row, and in the 0th row I'm going to get the first value, and then I'm going to multiply that value with our z, and in z also we need to get the first value because this is our z. Let's take, and we have 1 1 1 1 1 1, and we have some values here, so we need to get these values, not these ones. Okay, so let's, okay, now what we need to pass here, we also need to theta 0 0. So this is the basic formula that we have been using from the first video in machine learning course, so I do not need to explain this. And this is our x basically. Also what we need to do is z1. Yeah, so this is correct. Now what I am going to do is y list equal to y list dot append equal to y. Okay, and now we have this. So I have implemented this, and I have basically, what I have done here, I have added 1 1 1, a column of ones in front of x. Okay, so now we have this data as well. Okay, so it is showing us an error, data type not understood. So guys, what we have to do here is we have to use a tuple. Okay, now it should work. Yeah, it is working. Okay, so we have our shape here like this. We have 100 examples and two features, in which one feature is a dummy feature. So let's use the predict function now. So let's take y pred equal to predict, and in this we are gonna give x, we have to give y, and we have to give x test. So it is showing us an error. Okay, it is capital Y. And now theta dot a into b, so it is showing us an error with the shape. Okay guys, so the reason is that we have y dot shape as this. So what we need to do is y equal to, or I should better do it up here. So I need also do this np y dot d shape. So we have to do this d shape here. Now if we will run this, and it is showing us an error, let me just run it from start here. Okay, and now it is giving us another error, and the error is that we need to change this instead of this. So it should work now. Okay. So guys, the error that it is showing, the basic, this is the main problem with closed form solution, because you cannot find inverse of this kind of what do we say, because of these values. So let's take them as -5 to 5. Now it is going to be okay, and as you can see here, there is no error. And the reason behind that is because when we were doing this operation with those values, there were not a possible of getting a inverse of that. Not for that, but of all of this, there is not a possible combination to get an inverse of this matrix. So that's why it was not working. Now if we will see, we will have y_pred, and it is appears to be 0. Oh yeah, I also need to return this, return y_list, and we have these values here. Okay, so what I am going to do is I'm going to get this data again. Let's take this. Okay, and let's do xtest. Yeah, so we will have xtest here. So plt.plot, and what I'm going to do is I'm going to plot all these values. So let's take xtest with y prediction, and let's make give some color. So color is going to be red. So as you can see here, we have a line like this. So this is the beauty of this, so that you can non-linearly separate any data. But the disadvantage of this is this, that like as we had to get 100 output from this, we need to get 100 output, so we had to run all of this by 100 times. Why is that? Because we are calculating the distance for every kind of input. So if we are going here, then we are calculating the distance from this point to all other points. If we are getting this, if we are getting this, then we are getting the distance from this point to all other points. So that's why we are running it every time, and that's why it is not used too much. But I thought that you should know what is locally weighted regression, and there is nothing much to it. We have already seen these formulas. We just had added w in this, and to find the w we wrote this function. So I don't think there's nothing to explain here except this part, which I already did, because what we are doing here is basically we are squaring a matrix. So for matrix square, we have to use this formula. We can use this formula basically. And so this was it for this video, and I hope that you understood like what I am doing here. It is not that much important for practical aspects, but yes, to understand things better in machine learning, you should know this. And in future videos, I am also going to make videos on an algorithm that is going to linearly non-linearly separate this data, and you do not have to run this equation again and again to find every input. So thanks for watching, and I'll see you next time.